Good afternoon, everybody. Welcome to the session. My name is Rajesh Battala. I've been working on Citrix almost 3 years. I've been working CloudStack from 2011. Today, I'm going to talk about automatic workload management in the clusters managed by the CloudStack. So we heard the terms like green computing, green IT, and all for the energy efficient solutions in the data center management actually. So these terms have evolved such that IT people want to manage the data center in an efficient way to reduce the cost and all like that. So how this CloudStack can help the data center management to have efficient data center management. So the problem is, in the clustered environment, we have a pool of service nodes with VMs running on them. Virtual machines are launched in some nodes and released from other nodes periodically. After some amount of time, we observe dispersion of the VMs along the pools of the nodes. So how we are going to solve, how CloudStack can help to solve this kind of issues. So how this, this is how a normal deployment works. So you have clusters of Z server, Hyper-V or KVM, whatever, and whenever the deployment happens in the CloudStack, CloudStack uses best algorithms like first fit or best fit algorithms to deploy the virtual machines. So whenever it's deploying, it finds the right host to accommodate the such that it can use the host efficiently. But after some time, so when the VMs are destroyed or stopped or migrated from one host to the other host, so this could be a VM host cluster states in the host. So you see if the VMs are running in dispersed mode in the clusters actually. So disadvantages of both scenarios is like you see this host. There are some hosts which are left idle but still running, and there are hosts which are capable to accommodate the other workloads, but as it is got deployed already previously in other hosts, it still continue running over there like that. So we can solve this issue or kind of scenario by doing automatic workload management. So what will happen if we implement that automatic workload management is, it will improve the utilization of the host and reduce the cost of management and improve bandwidth availability, and a lot more use cases are there. So how to resolve this kind of issue? So what we can do is, we can monitor the host capacity and the usage of the host, and find the deployment model, the host being used, like the hosts are deployed in the dedicated mode or in a free mode, and the hosts are deployed, the VMs are deployed in the zone-wide primary storage mode, etc. And live migrate the VMs from the less deployment host to the best possible host. Choose the best possible host depends on the characteristics like CPU, memory, free capacity available to accommodate where it can accommodate the VMs running from the other host within the cluster. So once the best hosts are chosen, provide the info to the user to execute the action plan. So we can do a capacity planning. We can generate a capacity planning by doing the usage of the by analyzing the capacity and the usage of the servers, and we can generate an action plan for the users. So now when you go to the so either we can present multiple action plans to the user, or you can configure such that you can deploy an automatic plan for that. So once an action plan is chosen, the action plan will contain such that migrate the VMs running in this host, from A host, B host, C host to D host, such that the VMs will be running in an efficient host, and it can use the proper host actually. So according to the action plan, the VMs will be migrated. Once the VMs are migrated, the sum of the hosts which will be empty. So as VMs are got migrated from within the clusters, there is a chance that some of the hosts will be empty actually. There won't be any workloads running on that host. So what we can do is mark the host in maintenance mode from the CloudStack perspective and shut down those hosts. So when there is a peak of demand or user request, send a WL packet to the host such that the host will come up automatically whenever there is a demand actually. So when you look at this host, So if you look at the last in the cluster in the KVM host, which is after the after the VM, so that host is idle actually. So what we can do is we can migrate, we can turn off that host from the CloudStack, and once there is a requirement or if there is a demand or while doing the usage management, if we see there is going to be a deployment and there is a compute is required for that, automatically what we can do is from CloudStack perspective, we can send a WL packet in the LAN, then according to that the host automatically will be in the powered on state. Once the VM, when the host is in powered on state, automatically the host will come to connect to the CloudStack. So then it will be ready for the taking the deployments actually. So this will help the IT to reduce cost, manage the data center efficiently and effectively, minimizing carbon emissions. So after server consolidation, what happens is after the consolidation, after the any of the plan got executed by the user, so this how it will be. So the VMs will get migrated from all the hosts to a proper host, which it can take the loads to run for that, and mark the VM and mark the host which are in ideal state or which are not having workloads to be in down state actually, or we shut down the host. So the main thing is how to choose which host is better to accommodate host, or which host is better to bring it down. So we need to select the best server consolidation algorithm to find the best suitable host for consolidation. So we need to take into account several constraints to select consolidation model. The first set of constraints is related to live migration technology. As we are leveraging the live migration technology here, so we need to take account of the live migration technology factors while generating the server consolidation algorithm. As we go into reallocate the VMs by migrating the nodes, we need to consider the constraints of live migration technology. Currently, live migration requires having the compatibility virtual software, comparable CPU types, similar network connectivity, and usage of shared storage on both the source and destination. Secondly, it is necessary to limit the upper bound of CPU utilization of the single node by some threshold value. This is done to prevent a node CPU from reaching 100% utilization. The motive behind this is that 100% utilization can lead to the performance degradation of the servers. So make sure that we don't bottleneck the available host such that as we are migrating the virtual machines from one host to the other host, we should not make sure that other hosts get bottlenecked over there. Furthermore, live migration technology also consumes some CPU cycles. Keep CPU utilization below the threshold value allows retain certain level of CPU throughput. So when I was going to the server consolidation algorithm, what is suitable for this kind of scenarios? So by generally for any capacity management tools implement bin packing algorithms, either it be best fit decreasing or first fit decreasing algorithms. But I saw a recent paper where the server consolidation algorithms is generated, or the plan is generated by using live migration technology. There is something called Serkan algorithm. So this algorithm inherits some of the properties of the first and best fit, which try to minimize the number of nodes used. However, we not only aiming to minimize the number of nodes used, but also to minimize the number of migrations we have used. Hence, these algorithms behave differently from the ones related to bin packing. So this Serkan algorithm, at max, it taken the consideration of as we are live migration technology and try to generate action plan to migrate the VMs such that it can consolidate the servers and make use of the live migration technology. And it also makes sure mainly such that it blindly does not migrate all the VMs. It makes sure that the number of migrations from one servers to should be minimum and should be best for the server consolidation. So my proposal for that, so this Serkan algorithm only considers a live migration technology only to just generate the server consolidation plan. My proposal is, so this algorithm will inherit some of the properties from Serkan algorithm and consider the following properties to select the host for consolidation. So when generating the server consolidation algorithm for the host which are in the clusters, so apart from the live migration technology, what we can do is, what are the other factors it has to consider is, schedule VM tasks which are, so when you are trying to migrate a VM from one host to the other host, we should consider is there any scheduled task for the VM are present, like the snapshots are, is there any snapshot schedule for the VM, or any least, is the VM is having a least time, like it's another an hour or 2 hours is going to be terminated like that. So we need to consider these factors like that. So if it's in another 5 minutes there is a snapshot is scheduled for that VM, so we cannot consider that VM to be live migrated. Or if there is a VM that there is a least time for the VM, like in another 1 hour or 2 hours it's going to be terminated, should not be considered for the migration. And make sure that, and we should consider the zone-wide storage availability such that it has a view of lots of other hypervisors within cluster, apart from within same clusters, it can across the clusters in the same zone, it can figure out whether it can migrate the VM across the clusters actually. We have thus factor can be considered by using if the clusters are configured with the zone-wide storage. And we can take the accountability of the storage migration availability also while generating the server consolidation plan actually. Hence, this algorithm behave differently from the related ones. So reference for the circle algorithm, there's a paper published over there, and yeah, yes.
Is this already in CloudStack, or?
No, it's not. It's just a proposal I'm just making for them. Yeah.
How do you avoid having all your eggs in one basket? If the primary criteria to consolidate all your systems is like based on available resources, what happens like when you have multiple VMs that are shuttled onto a single server, and then you lose that piece of hardware, and then suddenly you get a massive hit on the application? Is there any way to go and take into account relationships between VMs such that a single hardware failure after this consolidation effort doesn't kill the whole thing?
Okay, that's very good actual point. So we can consider that as a property when implementing this, generating a server consolidation algorithm actually. So we can keep the properties, and the server consolidation algorithm can generate lots of plans and provide the plans to the admin. So admin can execute one of the plan, or it can choose one of the best plan to execute it automatically actually. That's my point.
That with affinity groups already, anti-affinity groups.
Sorry?
You probably can achieve that already with anti-affinity groups.
Okay.
So you mentioned in your algorithm that you were taking into account CPU utilization on your nodes, not just CPU allocation. Would you also take into account CPU utilization on the VMs so that you're not pushing all the VMs that are maximizing their CPU utilization to the same node and wasting resources in that way?
Yeah, I got it. Yeah, yes, you should. We'll be considering that also in the property of my own proposal. We'll be considering this property such that because there's no point of the VM is already touching the highest CPU and does not make sense to migrate the VM because it's going to cause a issue over there for the applications actually. Yes.
Are you going to apply that to the actual provisioning resource allocation also, or is it just separate? The VM might provision when the customer comes in, there is a resource allocation during the provisioning, right?
Okay.
So are you going to apply those concept algorithm into that, or?
Yeah. During deployment, there are planners which will consider the best host where it can deploy that VM actually.
Yeah, but that also needs to. I think that is also very useful.
Okay.
Part of the deploy VM, you already have planners, say best fit. So the question is, can we have even this proposal come into play at the deploy VM? Okay.
So because during the first provisioning, part of them can be very useful.
Yeah, so we should be able to extend it to the deploy VM as well.
Sorry, one question. It seems to me that a bottleneck here is the time to migrate or to migrate a VM, you have to stop it at this point and then create a...
No, actually it's a live migration. So
Okay.
it won't be required to stop. It's not a cold migration, so there won't be downtime. But according to the virtualization software, there can be a bottleneck. Like if the migration across Zen server to in a VM which is running on Zen server, if that software has a bottleneck to do a live migration, or when the application is not running or something, it's up to the software actually.
There is migration between different clusters as an FQR. I don't know if it's possible. If you're running a Zen server and then you have a VMware, can you do?
No, that will not be live migration. So that's a totally different.
No,
Even
if you shut down, it's not possible, right? The live migration, if you're talking about is live VM plus storage migration. If you have a Zen host, for example, you can do it without zero downtime, right? Or if you have VMware infrastructure, you still can do VM plus storage live migration without any downtime. Plus, another point is he was talking about zone-wide private storage availability, wherein storage is across clusters,
So you
and
cannot
then
have
just
like global storage.
move the VM across to different hosts. The storage is not at all required.
Okay, so it will not go for local storage. Got it.
So is that your inside situation, inside projects, or is that open?
so it's open source thing. So I haven't implemented. I'm just making a proposal, and after that I'm going to write a FS for the same thing. We can where anybody or
One single line of code being written by
You guys should try publishing it in like a journal.
Okay. So it's not. It's just the concept.
exactly, I shared the concept.
So have you considered, so I think the live migration is an interesting use case, but it's, as you pointed out, has a lot of constraints around it. So there may not always be opportunities to do that. Have you considered scenarios where, you know, taking advantage of when customers actually shut down a VM for whatever reason, being able to, reallocate it to another?
so when you try to reallocate or when try to start the VM again, so it goes through the deployment model.
Yeah.
Through the deployment model, again there are planners which will find the best host. Again, according to the deployment of it is whether it has to go dedicated host for that, or it can be architected to a free model like that actually. So it's not be in case of stock VMs, this may not be applied actually. So mainly for it's already running for that case.
I have one more thing to add, sorry. So when you're migrating VMs, you're looking at CPU usage, memory usage, etc. of the host, right? There can be certain cases where the migration can affect the performance of the app running on the VM. For example, if you have an Apache server running on a particular host, it's getting X requests per second, and if you migrate it to some other host, you get, let's say, X by 2, right? But you would never know because you are only looking at host level metrics, right?
Correct. So for some of the VMs, I mean, generally we can get the VM metrics like the CPU utilization of the VM from the host metrics. We can figure out the CPU VM utilization actually. So if we include in the properties of the algorithm, so it can generate multiple algorithms, multiple plans where we can either that mean look at it and figure out, okay, this plan can be used such that the VM will not be affected for when it is properly utilized. Because like he raised all the point where if the VM is already having 100% CPU utilization, there's no point of migrating the VM to another host just because there is a free host available like that.
Great, when's it gonna be ready?
Any other questions?
Thank you.